In this video, we are going to discuss combining like terms. Let's start by looking at the definition. The definition says that we're going to add or subtract terms that have common variables or no variables at all. Let's look at an example. Okay, so in this problem, we have a segment, SW, and it's made up of two parts, ST, which is equal to 4N, and TW, which is equal to 10N. So what I'm going to do is I'm going to use my segment addition postulate and say that if I add my two smaller parts, ST and TW, that will give me the total SW. And then I'm going to substitute what ST and TW are equal to. So instead of ST, I'll write 4N, and instead of TW, I have 10N. And I know that those combined will equal 10W. Now I see that in my first and my second term, they both share this in variable. So those are like terms. They have common variables. So I'm going to combine those together. And if I take 4 plus 10, I have 14N. And that gives me my total SW. And that is my answer. Let's look at a second example. Here I have HL and LN, and those combine to give me the total HN. All right, so again, I'm going to write out my two parts. I'm going to say that my smaller part HL added to my other small part LN gives me the total HN. And then I'll substitute what I know those values are. So I'll take 5x in place of HL and 5 minus 4x in place of LN. And those will give me the total segment HN. Now what I need to look for here, because now I have three terms and not all of them match, is I need to see which ones have the same variables or which ones have no variables. And what I see in my first term is I have an x, and in my last term I have an x. And if I look at the number out front, I have 5 and negative 4, or 5 minus 4. And when I combine those together, I get a 1. And I'm going to leave my 1 looking like a little ghost, because usually whenever we have 1 as our variable, we'll just leave it invisible. But when I combine those together, my simplified expression is x plus 5 equals HN. All right, let's look at an example using angle addition. Now, angle addition says that I'm going to take my two smaller angles and add it together to get my total angle. My first angle is angle ABX, and I'm going to add angle, the measure of angle, put a little m out front, of XBC. And when I do that, I get angle ABC. So just like before, we're going to take our two smaller parts and add them together to get the total. I'm going to substitute the expressions that I know. So I know that ABX is equal to 12y plus 4, and XBC is equal to 7y minus 3. So I'll set those two up, and I know that they add to equal the measure of angle ABC. And now I'm going to work to identify my like terms. All right, so the first thing I notice is that I have repeating y values. So I'm going to take those, I'm going to take 12 and 7 and add them together to get 19y. Then I have my 4 and I have my minus 3x, and I don't have anything that matches those. So I'm just going to tack them on to the end and say that they equal the measure of angle ABC. Now, though, I want to make sure that I rewrite this expression so that my letters are in alphabetical order. When I do that, I'm going to move x to the front, and I want to make sure I keep the sign with it, so it's going to become negative 3x. Then I'm going to put 19y, because in the alphabet it's x, y, z, so x comes first. And then constants always go at the end. So negative 3x plus 19y plus 4 is equal to the measure of angle ABC. B, C. And that concludes our notes on combining like terms.